So with right triangles, you're really going to have acute angles that you're dealing with, right? You have a 90-degree angle, and so the other two guys have to be less than 90. We talked about that yesterday. And so that kind of limits you. Once you put it on the coordinate plane, you start seeing larger angles, even larger than 360. You can just, it's an infinite loop that you could do with angle measurement. So some terminology that you need to know. Initial side, unless they tell you otherwise, is going to start typically right here on your x-axis in the positive, all right? So unless you are instructed otherwise, this is your initial side. Terminal side, as it sounds, that's where it ends. That can be anywhere, all right? Positive movement. Positive angular movement on standard form right here is going to be counterclockwise, all right? So if I start here, positive movement, positive 160 degrees, will go this direction and end here, all right? Negative movement is clockwise. So I would start here at my positive x-axis and I would go clockwise. So then this angle right here is represented by negative 200 degrees. As in most things, positive and negative are just telling you how you moved, okay? They're just telling you direction, all right? Now you'll notice they both ended on the same side. These are called coterminal angles. They end at the same point. So 160 degrees and negative 200 degrees will look the same on the coordinate plane. They will look the same, all right? And so then you can find coterminal angles by adding a circle or subtracting a circle, right? So if I wanted to find a coterminal angle here, I would just take that 160 and subtract an entire circle. What is an entire circle in degrees? 360 degrees, right? So 160 minus 360, you'll notice, is negative 200, right? I could find a positive coterminal angle. I could start here and add 360 degrees, right? And so that would give me 520, right? Coterminal angles, there's a multitude of coterminal angles that you could have. They're always going to be 360 degrees apart when they're coterminal angles. It just means they start at the initial side, they end at the same point. Direction is positive or negative, and it just tells you movement. Did I go counterclockwise positive, clockwise negative? All right, so let's look at how we're going to use this. The first thing we're going to do is we're just going to see, can we approximate? So when I say draw, I really mean sketch. I don't mean get a protractor out and measure it. That's not what I want you to do. I want you to try to figure out where it is. And so this is a positive 210 degree angle. I know then that I am going to start right here on this side. This is my initial, and I'm going to go to 210 degrees. Well, let's think about this. We know every quadrant is how many degrees individually? 90, right? This is perpendicular lines here. So I know that this is 90. I know that that is 180. I know that this guy is 270 and this guy is 360. So where is my 210 going to land? Which quadrant? The third quadrant. All right, specifically, it's going to land about 30 degrees past, right? So 30 degrees past is about, that's probably a little off. Maybe about right here. Let me get a straight line because it's going to bug me. So I would say that's probably around 210 degrees. This is my movement. My angle measure is 210 degrees. So if you sketch it, you're really just trying to figure out about where in the correct quadrant you're going to land. All right. And a good measure is 45 is halfway through the quadrant. So am I before the 45 or after the 45, right? It says identify a positive and negative coterminal angle. So what I'm going to do is I'm going to take that 210 degrees and I am going to add 360 degrees. That will give me a positive coterminal angle. 570 degrees would put me at the same point. 570 looks like this, all the way around 360 and back. That's a 570. If I want to do the same thing, but I want a negative, then I'm just going to say, well, 210 degrees minus 360 degrees. That's negative 150 degrees. Negative 150 looks like this. Starts at the initial side, but goes in the negative direction. That's negative 150 degrees. The next thing is they want me to then write an equation that would represent every single coterminal angle for this guy. So to write an equation that represents that, I start with my angle, and then I say, well, it's going to be some multiple of 360 degrees. How do you write a multiple? Multiples are that number times something, right? But I want all of them, so I am not going to just limit it to a constant. What do you think I'm going to put there to represent? A variable. And so I'm going to say, well, that's n times 360. That will represent all of my coterminal angles. And they do this little guy here. N is an element of my, what number set is that? Meaning you're not going to multiply 360 by 1.5. That actually won't be a coterminal angle. That'll actually be an angle that's 180 degrees away from it. You have to multiply it by an integer. It can be a positive or negative, right? Integers are whole numbers and their opposites, but it does have to be a non-fraction or decimal, right? All right. So you can then take this and you can say, okay, I am going to give you a point that lies on the terminal side of an angle. All right. In this case, they said XY. All right. So what they did is I start here, here's my terminal side, and they have just given me an XY point that lies somewhere on this ray, this terminal ray, okay? How does this help me? Well, this X value represents this base of a right triangle. This Y value represents the Y, or the height of a right triangle, all right? And so when I have those two things, I can actually figure out my trig. here's what happens, and we're going to talk about this. The trig of this obtuse angle will be the same as the trig of this acute angle. The ratios will actually be the same. So the ratio of the sine and cosine will be the same. The only difference is you have to consider when I am dividing numbers, I potentially have a positive and a negative, okay? So in quadrant 2, my x is negative, right? And my y is positive. And so if I'm considering this angle, my sine is going to be my opposite. So like from this angle here that I'm talking about, this angle that we created over here, my y value is my opposite, my x value is my adjacent. This little r represents hypotenuse, okay? So when they hand you the xy, they have actually handed you adjacent opposite. They've handed you those numbers by giving you that xy value. They've given you the adjacent, and they've given you the opposite, all right? If I have adjacent and opposite, can I find hypotenuse? Yes. Hypotenuse is a squared plus b squared equals c squared. So when they say r is the square root of x squared plus y squared, that's literally just the Pythagorean theorem, right? They've just gone ahead and put the square root on for you, okay? Your r will always be positive. So while your x and y could be positive and negative depending on what quadrant you're in, your r is always going to be positive, okay? Because it is the square root of the sum of two squares, all right? So r is always positive. That's not going to affect whether your answer is positive or negative, but your x and y might. So the first thing you're going to do when you're handed something like this is you're going to take your x and y and you want to figure out your r, all right? And then if you can just remember, my y is opposite, my x is adjacent, and my r is hypotenuse, then this is the same thing as right angle trigonometry, all right? So I'm going to figure out my hypotenuse first, and I'm going to say, well, given what they have given me here, my r should equal the square root of 5 squared plus negative 12 squared. And they were nice enough to give me a perfect Pythagorean triple. 25 plus 144 is 169. 169 has a perfect root of 13. All right? So 13 is my r, or my hypotenuse. And now they want all 6 trig functions. Well, this is very simple. In fact, I don't even need a picture to do this. All right? My sine is always going to be my y value. Y value is opposite. So this is going to be y over r. So I'm going to say negative 12 over 13. You'll notice I used my negative, right? So in this case, my sine value is negative. That can happen. My cosine value, well, that's going to be x. X represents adjacent. 5 over 13. And my tangent is going to be y over x. Y over x. Y over x is the same thing as opposite over adjacent. Y over x. All right? Once I have the first 3, the second 3 are really simple. What is my inverse of sine? Cosecant, because they want to confuse us. That is also going to be negative. If your sine is negative, your cosecant is negative. Opposite or reciprocal of cosine is secant. So secant is just going to be 13 over 5. Reciprocal of tangent is cotangent. So cotangent is going to be negative 5 over 12. Very simple when you have a coordinate plane. You're literally just using Pythagorean theorem to find r. And then if you can just remember, sine y over r, cosine x over r, tangent y over x. And then your reciprocals are literally just flipped. All right? When you talk about terminal sides of a coordinate plane, you have to consider the fact that you have some that will actually end up on an axis, all right? And so these are actual special type of angles, and they're actually really easy because they are going to have like zeros and ones. So they're going to be beautiful little angles when you actually memorize these. So if you look at this one, it says a trigonometric ratio of a quadrantal angle is one whose terminal side lies on either the x or y axis, and it may be undefined. So keep in mind, if you have zeros involved, there's going to be a time when a zero causes a problem. When do you think a zero is going to cause a problem? Look at a 180-degree angle. What happens here is I have this little guy right here, 180 degrees, all right? So 180 degrees is right here, all right? So here's the thing. I have a terminal side and a beginning, so I have an side like that and a side like that, all right? For something like this, they are going to give me a point. So we just picked a point here. They said the point that they are using is -2, 0. That's going to be on that. It really doesn't matter which terminal point we use. You're always going to get the same ratio. So here's what we do. We use -2, 0, and we're going to figure out our r. We have our x value, which is our adjacent. We have our y value, okay? We're going to use that to figure out r. So r is going to be the square root of -2 squared plus 0 squared. All right? What is the square root of -2 squared plus 0 squared? It's just 2. So here we go. We're going to do our sine then, our sine of 180. That's going to be my y value, 0, over my r. That is perfectly fine. What is 0 divided by 2? 0. All right, we have my cosine of 180. That's going to be -2 over 2. So we're going to say that's -1. And then my tangent of 180 is going to be y over x, also not a problem. All right, here's the thing. Cosecant. What is cosecant? Cosecant's the reciprocal of sine, right? In this case, if I reciprocate sine, what do I have? A 0 in the denominator. This guy is undefined. All right? Secant's okay, because 2 over -2 is actually the same thing. That's still going to be -1. I also have a problem here. All right? This guy's also undefined. So when you land on an axis, they're really easy. They're always going to be 0 and 1s, I promise. It's always going to work out that way. Or they're going to be undefined. All right, and so we're gonna get into your basics of as we start building the unit circle. But 180 is a special one. So we have 90, 180, 270, 360, or 0 degrees. That's the same thing. And you're gonna find that those are always going to end up, when you start doing this process, you're gonna say 0s, 1s, and undefined. No matter what your terminal point is on those, you're gonna see that happen. All right, because when you calculate your r, you're going to end up with something like this. Why is that? Well, on this axis, my x is always going to be 0, right? Which means my r is going to be the positive value of whatever my y was, correct? Because it's going to be 0 squared plus y squared square root. Well, that's just y, absolute value of y. Here, my y value is always 0, so my r is going to end up being the absolute value of x, which means I'm going to end up putting either a number over itself or 0 over a number. You're always going to end up with 1s and 0s. Then when I reciprocate, I'm going to run into problems. I'm going to run into issues that happen when I flip and put those 0s on the bottom, depending on which axis I'm on. So this is always going to be, so we have 4 of these. We have 0 degrees or 360. 90 degrees is going to be a special case. 180 is going to be a special case. And 270 is going to be a special case. Anytime you hit an axis, you're going to get a special case. So just like you have special cases that end up on an axis, you also have some special cases that we're going to just memorize. And they come from special right triangles, which we're going to talk about. The first thing I want to talk about with reference angles is that your quadrants will determine your positives and negatives. You don't have to memorize this whole chart. Use your logic skills, all right? If I am in the first quadrant, I have a positive x and a positive y. My r is always positive, okay? Which means your sine, cosine, and tangent are always going to be positive because it's a positive over a positive every time, right? If I drop over here, my negative now, I have an x that's a negative, right? So which of these deals with x? Sine, cosine, or tangent? Which one of those will x affect? It's actually 2. So sine is going to be positive over r, which is always positive, right? Cosine is going to be negative over positive. So what is cosine? Negative. Tangent is positive over negative. So what is tangent here? Negative, all right? Here I have 2 negatives. Except for one, because tangent is y over x. So in this case, yes, my sine and cosine will both be negative. But then all of a sudden my tangent will be positive because I end up with a negative over a negative, right? Here, you'll notice these are just opposites of each other for sine and cosine. Here, my sine is negative, my cosine is positive, again, my tangent is negative. So anytime your sines are the same, your tangent's going to be positive because it's same sines. Anytime your sines are opposite, your tangent's going to be negative. But you don't have to try to memorize this little guy. You just have to know x and y. And I think you know in your coordinate plane where x is positive and y is positive, right? And then if you know y over r, x over r, y over x, that's basic pre-algebra. When I divide a negative by a positive, I get a negative, right? That's basic information. So you're just pulling together some basic information here to figure out how this affects you. So how does this help me with reference angles? All right. There are 3 basic reference angles: 30 degrees, 60 degrees, and 45 degrees. All right. These angles come from special right triangles, which I'm going to refresh your memory with in just a second. And what you'll find is a lot of these angles, in fact, when we start building the unit circle is built off of these 3 angles: 30, 45, 60. Every single one of your unit circles, other than the ones that end up on an axis, are going to come from the sine, cosine, and tangent of a 30, 45, or 60 degree angle. And so when I have this angle here, let's say he is 225. How far past this axis did I go? Well, I went 45. A 225 angle and a 45 degree angle are going to have the same exact sine, cosine, and tangent. The only difference is 45 drops me off in the first quadrant. 225 drops me off in the third quadrant, right? A 45 will have a positive, positive, positive. Boom, boom. There we go, right? It will be the same number, except for 225, I'm going to have negative, negative, positive as my answers. The numbers will be the same. All I change is my signs, meaning not sine, cosine, my positive, negative signs, okay? So reference angles help you. If you know those 3 angles, then you can apply them to those reference angles, and it will help you figure out what it is, all right? Always in standard position. When you talk about reference angle, you are talking about the distance from the x-axis, all right? So like 120. 120 is here. I want to know how far from the closest x-axis I am. Well, 120, the closest x-axis is 180. So I am 60 away. 225, the closest axis was 180. So I was 45 away. Here, 330, the closest x-axis was 360. So I'm 30 away. 420, well, that went all the way around, and his closest x-axis was actually 0 here, 360. So that means I am 60 away. So you're only looking at x-axis for reference angles. My closest x-axis tells me my reference angle. So let's look at these 3 guys. This should bring back haunting memories from geometry. All right, special right triangles. All right. For a 45 degree triangle, right? 45, 45, 90. My side lengths are the same. My hypotenuse is the square root of 2 times my side length, all right? Since we're talking about ratios, remember equivalent ratios always reduce to the same thing. Instead of using an s and a square root of 2s, you can just say 1, 1, square root of 2. 30, 60, 90. My short side was 1. My longer side, you multiplied by the square root of 3. Your hypotenuse, you multiplied by 2. We're talking about ratios here. Similar triangles will have the same trig, okay? So you don't have to worry about what the actual numbers are. Just you can use 1, square root of 3, and 2. All right? So this is a 45, 45, 90. This is a 30, 60, 90. This is where we're going to get all of these guys. Now, here's the thing. You need to memorize this chart. It will make your life so much easier. I'm showing you what it's based off of, but I promise on a quiz or test you don't want to draw it, all right? You just want to memorize it because they're not bad. 30 degrees. The sine is 1/2. The cosine is the square root of 3 over 2. What do you notice about 60? It's just flipped, okay? So the sine of a 30 is 1/2. The cosine of a 60 is 1/2. The cosine of a 30 is square root of 3 over 2. The sine of a 60 is square root of 3 over 2. All right? Now here's the thing. Tangent. There's another way to look at tangent. You can memorize him. You're more than welcome to memorize him. I don't care. But I will say the tangent is always going to be sine over cosine. All right? Remember on your coordinate plane, it was y over x. All right? So tangent's always sine over cosine. So if you just remember these two lines, you can actually calculate tangent if you don't remember him. So let's look at just the 30 one. All right? If I did sine over cosine, all right? How do I do two fractions like that? Keep, change, flip, right? So I have keep the top guy, change it to multiplication, flip it. All right, what's going to happen to those 2's? They're going to cross cancel. I get 1 over the square root of 3. Well, hang on. Why does that say square root of 3 over 3? What did they do? Yeah, they just rationalized it. So this is all they did. All right, so on this chart, while it looks a little overwhelming, first of all, sine and cosine of 30 and 60 are literally the same thing, just flipped, right? And if you don't remember tangent, just do sine over cosine, keep, change, flip, and calculate it. The easiest one to remember is 45. Look at 45. He's beautiful, all right? So it comes from this. It comes from 1 over the square root of 2, and they just rationalized it. So 45 is square root of 2 over 2, square root of 2 over 2. Tangent. Well, why is tangent that way? Well, because if I put sine over cosine, I have a number over itself, which is literally 1, all right? So all of your reference angles come from these 3 angles. And if you can remember those 3 angles with your sine and cosine, when we move to unit circle, that is the entire unit circle. How does it help? Look at this guy memorized. All of a sudden, you know the 3 trig functions of 210. All right, so example. State the exact values of the 3 basic trig ratios. All right, let's look at 210. What is the closest x-axis to 210? The closest x-axis to 210, 180, all right? So I'm going to say 210 minus 180, what do I get? 30. They want my 3 trig functions. Well, if you have, for a 30 degree, my sine is 1/2. The only thing I need to know is what quadrant is 210 drop you off in? Which quadrant? Right, so this guy right here. What do I know about my x and y value down there? They're both negative, negative, right? And yes, my tangent's positive. So my sine is going to be negative 1/2. All right, cosine of this guy. Well, cosine, if we remember our chart, is square root of 3 over 2. But what do I know about my x value in that quadrant? It's also negative, right? My tangent, and even if you don't have it memorized yet, it's square root of 3 over 3. Tangent is going to be y over x, negative over negative. So what is he? Positive. Those are my 3 trig values of 210. That's how reference angles help you. All right? Because while this is 210, it's going to have the same trig functions of that 30-degree angle. The only difference is what quadrant are you in? Do you need to use positive or negative? All right?